So let's go ahead and do this example. We have r of x equals x minus 1 over x squared minus 1. So we're going to find all of the information for this function. It's going to go in the same order. It's just a different equation, so you'll see kind of different results. So for starters, we usually try to find the domain first. For me to do that, I'm going to factor my numerator and denominator and go from there. So my numerator is already in factored form. My denominator, I can factor it with a difference of 2 squares. It looks like this. Now, trick is, I know you can see that there's a factor that's in common. Before you cross it out, super important, you have to judge its domain. So you're looking at the denominator and seeing when it will equal to 0. So I'm going to look at x plus 1. I'm going to say that can't equal to 0. Same thing to this one. It can't equal to 0. Otherwise, you're going to divide by 0, and that's going to be a problem. So there's two values of x that are going to be on the restriction for our domain, one of which is x can't equal to -1, and the other one is x can't equal to 1. Again, super important that you figure out the domain before you cancel out any factors. That's why that's step number 1. Now, step number 2 is then to figure out what is your reduced equation. So this is when you can say, oh, look, I have an x minus 1 on the top and the bottom. I'll reduce that out. That leaves a 1 on the top and technically a 1 on the bottom with the x plus 1. So this is kind of like our new reduced equation. Once you've figured out this equation, you can actually use this as like our new r of x, because it will act like how r of x will for most of the other things that we're going to find. So because we did cancel out a factor, this is going to be our first example that has a whole. So I'll say a whole exists because you canceled out a factor. Since we canceled out a factor, and specifically, I need to find out where the whole is. So this is going to be me figuring out where the whole is. So our factor that we canceled out was x minus 1. That's going to help me figure out where the whole is. I'm going to say x minus 1 equals 0, add 1 to both sides, and then I'll get x equals 1. But again, a whole is going to be an xy coordinate. So I need to figure out the coordinates of that. We just figured out the x coordinate. Now, if you put 1 back into your function, like the original one, we're going to run into problems. Let me show you. If we do 1 minus 1 over 1 squared minus 1, you see how you get 0 over 0? This is when your calculator will give you sad faces because you can't divide by 0. So we cannot substitute 0 back into the original. We have to substitute 1. We can't substitute 1 back into the original, but we have to substitute 1 back into the reduced equation. So I'll say substitute into reduced equation. If you don't substitute into the reduced equation, you're going to have that trouble where you're dividing by 0 and then wonder, how do I find the coordinates of that whole? So if I substitute into the reduced equation, basically put in a 1 for x, notice my denominator won't be 0 if I'm using this reduced one. It will be 2. So the whole will be at 1 comma 1/2. So that's important to make a note of. So when you're making a graph, you should consciously be putting an open dot at 1 comma 1/2 when you're graphing it. That's basically what that means. Fourth one is to find the y-intercept. So to figure out my y-intercept, just like what we talked about before, you're going to substitute in x equals 0, so basically r of 0. Again, I'm going to use the reduced equation. I mean, you could use the other one as well. You should still get the same answer. I just think it's easier to substitute into the reduced equation. So I got 1, aka my y-intercept is 0 comma 1. Again, it's going to be nice for you later, since we're going to eventually be graphing all of this, to write them out as coordinates. It's just going to be so much more helpful for you later. Next one is x-intercepts. So for us to find x-intercepts, it's going to be the other way. Instead of putting x in for 0 in for x, we're going to do the other way. So we'll say, what if I set 0 equal to 1 over x plus 1. So I'm again using my reduced equation just because it's smaller, it's more simple, I don't have to deal with as much. Try not to get freaked out. Same thing, you want to get x out of the denominator by multiplying x plus 1 on both sides. You'll notice it cancels out on the right-hand side. I get 1 on the right-hand side. 0 times anything, though, is 0. So you notice I get this equation 0 equals 1. That's impossible. So when you get to this situation, you're trying to solve for an x-intercept. I want you to know, because this is impossible, that 0 equals 1, that means there's no x-intercepts. Because I tried to solve for them the way that you're supposed to, but this one has no x-intercepts. Okay, our next step is then to find out about our asymptotes. So I'm going to go back up here and look at my handy dandy flow chart. Again, you're going to be looking at vertical asymptotes as well as oblique and horizontal asymptotes, depending on which one this one has. So let's start with vertical asymptotes. So this one, it tells you for vertical asymptotes, you have to set the denominator in lowest terms equal to 0. So our lowest terms is going to be this equation, 1 over x plus 1. So I only have one vertical asymptote, and that's going to be at x equals negative 1. Super important you realize that there is not a vertical asymptote at x equals 1 because there is actually a hole at x equals 1. So that's why you have to use your lowest terms equation. On the right-hand side, either I have oblique or I have a horizontal asymptote, and that's all dependent on the degree of your numerator and denominator. I always like to go back to my reduced version, so let's talk about this. The degree of my numerator. This one is 0 because there's no x in the numerator, so the numerator can be like 1 x to the 0, that's the same thing, right? So the degree of your numerator is 0. Degree of my denominator is 1, since the highest exponent for that is 1. That means I'm not looking at this situation. My degrees are not the same. They are actually different. It's either the numerator's degree is going to be bigger or the numerator's degree is going to be smaller. This is a situation where the numerator's degree is smaller, so I have a horizontal asymptote at y equals 0. Last but not least, we're going to figure out if there is any cross points for this graph. You might eventually realize like when you will have one, especially after we found all that information. But let's go ahead and find out cross points. So you'll get your answer that we got from number 6. And we will substitute that in and solve like a system of equations. So we'll take our horizontal asymptote, we'll take our reduced function just because it's going to be easier to solve, and we're going to set them equal to each other, see if there's an answer that comes out. So 0 equals 1 over x plus 1. Will this actually give me a cross point? If you recognize this, it might be because we actually solved this equation before. But just to show you how you would approach it, you're trying to solve this for x. Let's get x out of the denominator. X plus 1 times 0 gives you 0. On the right-hand side, everything canceled out except 1. So we're back at this place again where like you canceled out all of your x's, and this is not a true equation. So this is an example of something where we have no cross points. So that lends itself to a less weird graph, I guess, because it doesn't have any cross points for your horizontal asymptote.